Welcome and study with Tanzania Institute of Education.
We are going to use what we know about triangles to expand our knowledge of parallelograms. Let's start with the midpoint theorem. What exactly is a midpoint? The midpoint of a line is a point that is exactly halfway on the line. If this line is a racetrack, and Fidel and James are racing along it, to see who reaches the midpoint first, Fidel has won. He reached the halfway spot first. Not sure James understood about the midpoint. Archimedes, the great ancient Greek mathematician, physicist, engineer, inventor, and astronomer, has been credited with finding the proof for the midpoint theorem. The theorem states that, in a triangle, the line segment that joins the midpoints of any two sides of the triangle will be parallel to the third side and equal to half of it.
Let's illustrate this, shall we?
We'll call this triangle ABC and mark in the midpoints of sides AB and AC. In the triangle, X is the halfway point between A and B. X is also the midpoint of side AB. In the same way, Y is the halfway point between A and C, and Y is also the midpoint of side AC. The midpoint theorem tells us that the line XY is parallel to BC. It also tells us that the line XY is exactly half the length of BC. And that's all there is to it. If we have a triangle with a line drawn in to join the midpoints of two of its sides, then we immediately know a whole lot about this line without having to measure anything ourselves. When someone talks about the corollary of something, they are talking about something that you know is true because of some other thing that has already been proved. For example, if you'd proved that A plus B equals C, you can see that B has to therefore be equal to C minus A. This is the corollary of the original proof. So the corollary of the midpoint theorem is this. If we have a triangle with a line segment drawn which joins two sides of the triangle, but we don't know if this line joins the midpoints or not, all we need to do is to look and see if that line is parallel to the third side and equal to half of it. If it is, then this line must join the midpoints of the two sides. The midpoint theorem tells us so. Do you remember how to find the area of a triangle? We use the formula. Area of a triangle equals half the base multiplied by the height. The height of a triangle is the perpendicular distance from the triangle's base to the opposite vertex. This means that if we put a row of triangles together between the same set of parallel lines, then they all have the same height. If all the bases of the triangles are equal, then we know that the areas of these triangles are all the same. Why? Because regardless of the triangles looking different, we are using the same variables in each area formula. Our knowledge of triangles can help us when it comes to working with quadrilaterals. For example, if you are asked to find the area of a parallelogram, there are certain steps you can follow to find it. Diagonals of a parallelogram divide it into two triangles that are congruent. Whichever diagonal we choose, we end up with two triangles that are exactly the same and have exactly the same areas. This means that to find the area of a parallelogram ABCD, we need to add together the areas for the two triangles ACD and ABD. Because we know the formula for finding the area of a triangle is area equals half the base multiplied by the height. And we know the two triangles ACD and ABD are congruent. All we have to do is add the areas of the two triangles together to get the area of parallelogram ABCD. What happens if we add these two together? 2 times half BH gives us BH, and this is how we work out the area of any parallelogram, base times perpendicular height. Just as we did earlier with triangles, we can put a row of parallelograms with the same bases together between the same set of parallel lines, and we will know that they all have the same height. We know that the areas of the parallelograms are all the same, because we are using the same variables in the same area formula. The heights are the same, and the bases are the same, so all of these parallelograms have the same area. Let's combine what we have just discussed about triangles and parallelograms into one idea. A triangle and a parallelogram on the same base and between the same set of parallel lines will have the same base and height. We can find the area of the parallelogram by multiplying the base by the height, and we can find the area of the triangle by multiplying 1/2 by the base and height. So if a triangle and parallelogram share a base and are positioned between the same set of parallel lines, then the area of the triangle will be exactly half the area of the parallelogram. Easy!